Now we'll talk about the state of a gas. In analyzing gas laws, we have slightly discussed about the states of a gas. Let's discuss what do we exactly mean by state of a gas. We can state at any instant state of a gas is defined by its thermodynamic coordinates. Thermodynamic coordinates are basically pressure, volume and temperature. These are the thermodynamic coordinates of any gaseous system. At any instant when the gas is at a pressure P, volume of gas is V and its absolute temperature is T, then pressure, volume and temperature combinedly defines the state of a gas. We can state whenever a gas is enclosed in a container and its pressure, volume, temperature are changed by a particular process, then we can state, say initially, say for a given situation, initial state of gas is say P1, V1 and T1. That means initially a gas is at pressure P1, its total volume is V1 and its temperature is T1. And say if it is heated or by some particular phenomena it is expanded or compressed or by any means its pressure, volume and temperature are changed, then we can state that we are changing its thermodynamic state or gaseous state from initial state to final state of gas, in which say its pressure, volume, temperature becomes P2, V2 and T2. Then we can state in the situation between the two states, by gas laws we can state, by gas laws here if the total number of moles are conserved, we can use P1 V1 by T1 is equals to P2 V2 by T2. That is just a relation of mole conservation if no leakage of moles are taking place in the situation. In this example, we are given a cylindrical container as shown in figure, in which a gas is enclosed and it is given that its initial volume is V and temperature is T. And as no external pressure is applied on the light piston shown, the piston is light which is given here, the gas pressure must be equal to the atmospheric pressure. Obviously, if a lightweight piston is in equilibrium, on both sides its pressure must be equal. Now it is saying if gas temperature is doubled, we are required to find its final volume. And in its final state, if the piston is clamped, that means the volume of gas is kept constant and temperature is again doubled, and we are required to find the final pressure of the gas. In the solution we can state gas pressure we can simply write as atmospheric pressure, which is equals to P0, which is atmospheric pressure. If we talk about the initial state of gas, which we can call as state 1, we can write the pressure to be P0, volume is V and temperature is T. And keeping its pressure constant, its temperature is doubled. That means the gas state is changed in such a way that pressure is kept constant and volume is doubled to 2T. Here P0 is kept constant. As no external pressure is there, the gas pressure will always be equal to atmospheric pressure. So we can directly use the relation P1 V1 by T1 as P2 V2 by T2. So we can write V1 by T1 is equals to V2 by T2 as pressure is constant. So if temperature is doubled, volume has to be doubled, so final volume will be 2V. The piston will raised up in such a way that the volume changes to 2V. We can write in the state 2, final volume V2 can be written as 2V, which will be one of the answer for the first part of the problem where it is asking in the final state if the piston is clamped. So in the final state the volume is 2V when the piston was clamped. And again the temperature is doubled. That means this is state 2 when we can say pressure was P naught, volume is 2V and temperature is 2T. Now if piston is clamped, that means this volume 2V is kept constant. After clamping the piston, volume is not allowed to change. And again in the next state, say it is stage 3. In state 3 we can state volume will be 2V and now temperature is further double, that means changes to 4T. And we are required to find the final pressure, so we can use from state 2 to state 3, it is P2 by T2 is equals to P3 by T3. In this situation, we can say the temperature is doubled, then in this situation pressure must be doubled, so it will be changed to 2P naught. That means this P3 when we talk, so the final pressure will be 2P naught. That will also be the answer to the second part of this problem.